All right, going to throw down a quick little review video for simplifying radicals. So starting with number 1 here, if I'm just simplifying the square root of 700, a few different ways we can tackle this. I'm going to start by going 7 times 100. So literally 7 times 100. And then I see a perfect square here with 100. And the square root of 100 is 10 times 10. So there's my perfect square. So I could rewrite the square root of 700 as the square root of 7 times 10 times 10. If you work that out in your calculator, it equals 700. I should note I cannot break 7 down any further. So this is a prime factor, and then this is a perfect square. When we're working with a square root, we're going to look for pairs of numbers. One pair makes it out of the square root, one number from the pair, and then whatever else is still left inside, we rewrite inside. So the square root of 700 is equivalent to 10 rad 7, or 10 times square root 7. So again, now I have 200. That's fine. I'm going to do 2 times 100, and 100 is a perfect square, so I can rewrite that as 10 times 10. So the square root of 200 is equivalent to the square root of 2 times 10 times 10. And I'm looking for pairs. I have a pair of 10s. One makes it out, one stays in, and this is our solution. We can always double check to see if we did it correct by squaring our outside number and then multiplying that times our inside. So 10 times 10 is 100, times 2 is 200. That's our original. 10 times 10 is 100, times 7, 700. All right, 252. I'm going to break this down using my prime factors of 2. If I run out of 2s, I'll try 3s. If I run out of 3s, I'll try 5s, 7s, 11s. So my prime factors. So I'm going to break this down. 2 times 126. And then I can break 126 down. 2 times 63. And then 63 I can't break down using a 2 because it's not even. So I used up my 2s. Now I'm going to try 3. So 3 and 21. 3 and 7. And the whole idea is that I rewrite 252 is equivalent to the square root of 2 times 2 times 3 times 3 times 7. If you put all of this in a calculator and multiply it up, it will make 252. And I got all of these numbers from here. So we have a pair of 2s, a pair of 3s, and a 7 all by itself. So I get 1 2 that makes it out of the radical. I have 1 3 that makes it out of the radical, and I have a 7 still stuck inside the radical. Anything that makes it out multiplies back together to leave us with 6 radical 7, or 6 rad 7. For number 4, I'm going to use my 2s, 3s, 5s, 7s, 11s. So start with 2. 2 times 80 makes 160. You can always divide. 160 divide 2 gives 80. 80 divide 2 gives 40. 40 divide 2 gives 20. 20 divide 2 gives 10. 10 divide 2 gives 5. So my prime factors, I used 80 up to make 40, I used 40 up to make 2 and 20, 20 to use 2 and 10, 10 to use 2 and 5. So my prime factors of 160 are 2, 2, 2, 2, 2, 5. 2, 2, 2, 2, 2, 5. Square root means we're looking for groups of 2. I have 2 groups of 2. This 2 and this 5 cannot partner up because they're not the same number. So one gets taken out, one moves outside. One gets taken out, one moves outside. My square root 2 and my square root 5 did not have partners, so they are staying inside. And now I'm going to multiply. So 2 times 2 is 4, and 2 times 5 is 10. Okay, I'm going to break down 512. This negative 4 is like waiting on the outside to multiply with whatever else comes on the outside. So let's see. If I break down 512, I can break it down using 2. And we get 256. I'm going to break down 256 using 2. And get 128. We'll break down 128 using 2 and get 64. Now if you run into 64 and you want to say, oh, that's a perfect square of 8 and 8, and then we can rewrite this as square root 2 times 2 times 2 times 8 times 8 and look for partners there. That would be fine. If you wanted to break down 64 using 2's, you could do that as well. It'll get you to the same answer. I'm going to shortcut that and multiply all of my outsides together and get negative 64 square root 2. For number 6, we have a getaway driver waiting outside. A jailbreak, we're going to break down 24 to 2 and 12. 12 is 2 and 6. 6 is 2 and 3. So this is square root 5, negative 5 times square root 2 times 2 times 2 times 3. I have pairs of 2's. So this is going to be a negative 5 times 2 that made it out. And then 2 and 3 stay inside. And now finally negative 10 rad 6. There are some faster, easier ways to do these, but this is consistently like you could just use these every time. So we have a negative 6 that's waiting. Break down 12, 2 and 6. 6 is 2 and 3. Pair of 2's, 1 makes it out to multiply with 6. 1, 3 is left inside. For number 8, 45, so I have a 7 waiting. 45 we're going to break down. I can break down using 3 times 15, and 15 is going to be 3 times 5. Pair of 3's, so 1 makes it out to multiply with the 7. A square root 5 still stuck inside, and we're going to end up with 21 rad 5 for number 8. For number 9, now we're working with adding and subtracting. So for these ones, we're going to make sure we have the same radical base that we're using, or same radical. And if we have the same radical, then all we're doing is we're counting up how many there are. So if I have 3 radical 3's, and I have negative 2 radical 3's, that's 3 minus 2, which is a total of 1 radical 3's. Or we could just write that as radical 3. So for number 10, I have negative 3 radical 6's and negative 2 radical 6's. I can combine negative 3 and negative 2 to make negative 5 radical 6's. We're counting up how many there are. Now with number 11, we cannot put a radical 6 and a radical 24 together. We can't count those up. So we're going to look to see if we can break these down. radical 6, I'm just going to focus on this by itself. In fact, this may make it easier if we cover it up. So let's think about it like this. If I were to cover up, I'm just going to cover all that up. Excuse me. Could I break down 6 at all? So 6 is just going to be 2 and 3. So that doesn't break down. So there's no simplifying here. Negative 2 rad 6 is still negative 2 rad 6. Now let's think about if we were to cover this up, could I break down square root 24? So I have a negative 3 multiplying with. 24 is going to be 2 and 12. 12 is 2 and 6. 6 is 2 and 3. A pair of 2's. And then 2 and 3 multiply back up to give us 6. So negative 3 square root 24 could be converted to be negative 6 square root 6. And now I have like radicals. So I have a rad 6 and a rad 6. So now I can count up. I have negative 2 rad 6's and negative 6 rad 6's. So I have negative 8 rad 6's. Okay, and we already learned in the last one that rad 6 doesn't break down. So this is plus 2 rad 6 already. But let's break down 54. 54 can be 2 times 27. 27 can be 3 times 9. And 9 can be 3 times 3. So I have a pair of 3's that make it out to multiply with this negative 2. So negative 2 times 3. Left inside, I still have a 3 and a 2, which multiply to make 6. So this gives us a total of negative 6 rad 6. And now I have like radicals, and I can combine these. So negative 6 plus 2 is negative 4 rad 6's. Let's look at 13. Now 13 is multiplying. There are a lot of different ways we can deal with the multiplying. But you know what? I'm just going to do this the most straightforward way. It's not the cleanest or fastest or most efficient way, but it's the most straightforward way. So what I'm going to do, I'm going to multiply what's inside of my radicals together. And when I work that out, I get square root 20 times 15, which should be 300. Now that I've multiplied them up, I can simplify square root 300. I'm going to use 3 times 100. And just like in our first couple problems, 100 is 10 times 10. So square root of 300 could be rewritten as 3 times 10 times 10. I have some pairs here, so a 10 makes it out, and a square root 3 stays inside. For number 14, I'm going to do the same approach. I'm going to multiply 15 and 10, and that's square root 150. And now I'll break it down. I'll break it down using 3 and 75. That didn't make sense. 2 and 75. And then I can break down 75 with 3 and 25. 25 is 5 and 5. So I have a pair of 5's. I have a 2 and a 3 that multiply back up to give me 6 in my rad. For number 15, this one we have coefficients of our radicals. So we're going to multiply our coefficients together. So we're going to do negative 3 times 3 and get negative 9. And we're going to multiply our radicals together. So I'm going to get 6 times 10. And get rad 60. Now this isn't our final answer because we could break 60 down. So negative 9 waiting outside to multiply with whatever we get. 60 is going to be 2 and 30. 30 can be 2 and 15. 15 can be 3 and 5. I've got a pair of 2's. 3 and 5 multiply back up to make 15. And so that means our final answer is negative 18 rad 15. For number 6, once again, we have coefficients that can multiply together to make negative 4. And we have radicals that can multiply together to make rad 15. And if I try to break 15 down with 3 and 5, nothing works. So negative 4 square root 15 is as simplified as it can get. Okay, for number 17, I'm going to look to reduce anything that our coefficients can reduce, anything that our radicals can reduce. So right here I see 4 and 10 can reduce to 2 over 5. So if I were to rewrite this, or we think about it as, excuse me, we're dividing by really rad 2 and dividing by rad 2. To simplify it, to reduce it, that would make rad 2 over rad 5. Now that I'm working with a reduced version of it, I'm going to rationalize the denominator by multiplying to get rid of the rad 5. I'm going to multiply by a rad 5 because a rad 5 times a rad 5 equals a regular 5. But with a fraction, I want to scale it, so that means I also need to multiply by rad 5 to the top, and when I multiply these together, I get square root 10, or rad 10. I can't break 10 down because it's just 2 and 5, and I cannot reduce this, so this ends up just being my answer. For number 18, I would look to reduce. I cannot reduce these. I have one outside, I have one inside. They're just different values, or they're not going to play nice together or reduce. So I'm ready to multiply rad 3 to the bottom and give me a regular 3. These cancel each other out to just make a regular 3. I'm going to multiply to the top a rad 3 as well. And I cannot combine, I can't multiply these to make like either 9 or rad 9. It just doesn't work because they're both not inside. So what I have is an outside 3 that's multiplying with an inside 3. What I am able to do from here is reduce my outside 3's. 3 over 3 makes 1. So this ends up just being 1 rad 3. Or I could just call that rad 3. Like these cancel each other out. And the last couple problems here. Again, if I can reduce outside, I will. 4 over 3 does not reduce, so it stays 4 over 3. However, I'm going to move this over a little bit. 25 and 15 do reduce by 5, so if I were to reduce 15 by 5, it would be 3, and this would be 5. So this would actually be square root 5 over square root 3. Reducing it up front just makes it smaller to work with in the long run. Now I need to get rid of this rad 3, so I'm going to multiply a rad 3 to get rid of it. So track with me here. I have this 3 in black that's just waiting to multiply with whatever. I then have my red and blue 3's that cancel each other out to just make a regular 3. I'll use a purple 3 since red and blue make purple. On top, I just end up with 4 square root 5. And now I'm going to simplify this. I get 4 square root 5 over 9, because that's 3 times 3. And there's nothing here that reduces, so this is my final answer. And for number 20, again, if I could reduce anything outside, I would. I cannot, so I'm going to end up with 3 over 2. If I can reduce inside, I will. 8 and 20 will reduce. 4 goes into 8 twice, and 4 goes into 25 times. So this is really a square root 2 over a square root 5. I'm going to get rid of my square root 5 by multiplying square root 5. And that just gives me a regular 5. So I multiply these, that gives me a regular 5. I still have a 2 that's waiting. And then up top, I have a 3 out front, and then 2 times 5 is 10, so I get rad 10. And then finally, 3 rad 10 goes over 10, and I cannot reduce 3 and 10, so this is my final answer. The rad 10 and regular 10 do not reduce because they're not the same radical. So this ends up being our final answer.